a computer doesn't understand if something's 0 and then suddenly is 1. It doesn't understand the transition from here to here, any gradient states in between. It just knows something is not there and something's there. That's all it can deal with. And it also knows that if there's 50 of something at one point, and then a split second later, there's 53 of them, it only knows those two things. It doesn't know anything about what happened in between. Good. So, inside a computer, what we need a computer to do is operate on very, very simple logic. And that logic is something is either on or it's off. It's yes or it's no. It's hot or it's cold. Silly song, sorry. So, how do you do that? You choose two digits, 1 and 0. What it actually means inside the computer is this. It means 5 volts of electricity is present, or 0 volts of electricity is present. That's it. By the way, for a very simplistic idea of how electricity works, you can kind of think of a battery, which we've all seen before, with a positive and negative. The best analogy, the best analog, like this is like that. The best analogy I've ever seen for this is to think of the battery as like a big giant pump, where a pipe comes into the pump, and the pump can accelerate and push out water. There's a big tank of water into that pump, and the pump pushes it out. It's an energy source. The flow of the water through the pipes does work and is also analogous to electricity. Water flowing equals work done. Water flowing equals electricity for the purposes of analogy. So what does this mean? It means there's a certain degree of flow, a certain amount of potential work that can be done called 5 volts. So, why 5 volts? I don't know. It's a really small voltage. It's easy to build something that can produce that amount of voltage. If they made it 110 volts, the power supply needed to be able to run a computer would have to be really, really strong. It's a separate thing, but it's kind of interesting. So, inside a computer, 1 just means at any specific point in that computer, if 5 volts is present. 0 means that there's no voltage present. It's that simple. So now you have a machine that you can control states of existence, conditions, by applying 5 volts somewhere or removing 5 volts from somewhere. How do you do that? You do that with a really, really cool thing called a transistor. A transistor is a special device for allowing or not allowing electricity to flow. How does it do that? Well, let's say you have this little device called a transistor, and it's got 5 volts of electricity coming in one side on a wire, and it's got a wire coming out the other side. You're looking to find out, can I or can I not get 5 volts there? And you can base a lot of decisions on that. For example, if there's a 1 there, if there's 5 volts there, it could mean, yes, I do want to print my document. Or no, I don't want to print my document. It could mean, yes, the person's actually entered the correct password. No, they haven't. Yes, no, on, off, that thing. So how do you control that? Well, this little device is almost magical. It's got a way, by bumping a very small amount of electricity at a separate piece of it, to allow or not allow electricity to flow. It's a gate. Open it, electricity flows. Close it, electricity doesn't flow. That's all it is. How do you make something like that? Well, it's fun. You take a special metal called a semiconductor. Semi means half. Half the time it conducts electricity, half the time it doesn't. How do you control when it does or when it doesn't? By the way, it's not half. It just means that it doesn't have to conduct, and you control whether it does or doesn't. How do you do that? Well, Here's a very simplified diagram or description of a transistor. You have a certain kind of material right here, and then the exact same kind of material right over here, and one that's different in between, and they're all physically assembled together. You have a wire going in, and that wire coming in has 5 volts of electricity. You have a wire going out, and it has, well, we're going to decide what it has. Whether it has 5 volts or 0 volts. Whether it has a 1 or a 0. Whether it has a yes or a no, essentially. But physically, in the real world, what we really care about is, does this device allow the electricity to pass, meaning there's 5 volts there, or does it stop it, meaning there's 0 volts there? The way you do that is by taking this middle piece of material and changing its characteristics so now it's like the ones on either end. Electricity flows. There's 5 volts here. Now you make it change back and it stops electricity flow. How do you do that? Well, the simple version, again, very simplified. The guys at Intel would slap me if I was this simple about it in front of them. This is a special material, mainly from a material called silicon. Silicon is like, it's a mineral. Mainly, the main ingredient is sand. But you can take sand, for example, and bake it, make it very pure, and then you can do special things to it. You can add other metals to it that change its properties. And one of the things you can do is add a metal to it that means that if you apply a tiny amount of, like, say, 1 volt of electricity to it, it'll warm up and it'll change characteristics to allow electricity to flow. And then when you remove that and it cools down slightly, now it changes back to its first condition, its first state, and it no longer allows electricity to flow. That is what makes computers possible. That's all there is. Because all you really need for a computer, for a digital machine to work, is for it to be able to differentiate between one of 2 states. That's all you need. A yes or no, a 1 or a 0, a plus 5 volts or a 0 volts, and that's how you accomplish it. That's what a transistor is.